Hey guys, so today I'm going to be showing you how to solve simultaneous equations when there's three equations. But the first thing I want to show you is do not use trial improvement, which basically just means don't put in random numbers until it works. The actual method I would recommend is to first label the equations. You're going to see that in this example it's not as important, but get used to it because I reckon it'll help later. So once you've done that, what you're gonna do is try to pick like any term you want really in any of these three. So for this one, I'm gonna go with x, and we're gonna go with the first one and the third one here. So just kind of solve it like you would any other simultaneous equation. But when I say pick a term, we mean like pick a term to get rid of. So once you got to this point, I would be labeling this as number 4, just to keep a track of it, which, like I said, it's not going to be as helpful in this one, but it will be in the future. Anyway, so whichever equation you didn't pick, what you're going to do, so in this case it's number 2, and whichever term you try to get rid of, you're also going to try and get rid of it in this one. So I'm just going to do basically the same thing, but I'm going to do number 1 minus number 2 instead of minus number 3. And again, it won't be as useful here, but we're going to label that number 5. Now that we have now that we have y and z, we can substitute that in. I'm just going to go with the top one because it's the easiest in my opinion. And then if we rearrange it and solve it, I mean, you can kind of tell from here, but x equals 1. So from that, your answer is going to be x equals 1, y equals 2, and z equals 3. And that's probably the easiest you can get just because there's no coefficient before any of these, but this next question will have that. Okay, so as you can see, this one's a little bit more complicated, but I'm just going to do what I did last time, which is label the equations, which is actually going to come in a bit more useful this time. So I think what I'm going to do, I'm going to try and get rid of this x here, and I'm going to use number 3 and 1 to do that, and I'm going to do 3 minus 1, not the other way around, just so there's no annoying negatives. And I'm going to label this one as number 4, because it'll make it a little bit easier to track later, and well, you'll see what I mean. Anyway, the next step, because we didn't do anything with number 2, that's the one we're going to put our attention towards, if you will. And I'm going to try and get rid of the x again because that's what we did last time. I think the way I'm going to go about this is 2 minus 2 lots of 1, which we can almost like shorthand write like this. I'm going to label that as number 5, and all of this labeling it's finally going to come in useful because now that we've got these two equations here, you'll notice that they only have two terms, so we can actually solve it like a normal simultaneous equation. I'm going to try and get rid of the y. So I'm going to take the 4. I'm going to take away 4 lots of this 5 here. Just a thing to be aware of because I nearly confused it. Remember that we're subtracting all of this, so there's going to be double negatives. Anyway, because we got 13z equals 39, we know that z is just going to be 3. Alright, I've had to zoom out a little bit because I was running out of room, but because we know that z is 3, I'm going to substitute that into one of the equations. I think I'm going to go with this one here because it's just a bit cleaner, but from there we're going to be able to figure out what y is. Okay, so now that we know y equals 1 and z equals 3, we're going to be able to come back to one of the original equations here, and I think it's a no-brainer. I'm just going to go with the first one here, and I'm going to write it here, but we're going to be able to figure out what x is from there. So from there, you've got your answer, x equals 2, z equals 3, y equals 1. What I would recommend doing is, because these questions are really easy to slip up on, I would just substitute those values into each of these equations. The first one we've already done, but number 2 and 3, just substitute them in and make sure they come out to be what it says. So because this came out to be 4, we know that it satisfies number 2. Don't stop there though, because there are some where it fits the first two, but it doesn't fit the third one, and it's kind of tricked you. So I'm just gonna make sure it's definitely correct, and I'm gonna substitute it into the third one. And because 2 plus 5 plus 6 does equal 13, we know that it satisfies, well, it satisfies all of these equations. So with that, your answer, because we've checked it, is x equals 2, y equals 1, z equals 3. Now, I don't think there's many forms that these questions come in, aside from sometimes it tells you like a quadratic sequence and like what they are, but what they come out to be. But it's literally just, it's pretty much just all of this, but in words. And you get some where the variables are listed as items. Again, just write out what the question says, and you'll see that it comes out to be a similar form to this. Anyway, I hope all of that helped, and I'll see you in the next part.